Alright, today let's do the hands-on for CloudWatch. We'll be automating trailing the logs, and the logs will be automatically put into the S3 bucket. We even don't need to create an S3 bucket. We'll be doing everything from Lambda. So let's dive into the hands-on for CloudWatch. Alright, we are at the AWS console. So the first thing would be to create a Lambda function. Let's go to Lambda. We'll be doing everything from the scratch. So let's first create a Lambda function. We'll be writing the name Cloud Guru Amit, maybe CloudWatch. Let's select the version. We'll be using Python 3.10. Let's use a role. I have already created a role which looks something like this. So we basically need access to S3, kind of full access, and also CloudWatch, especially the log streams and all. These are required, otherwise we won't be able to use the CloudWatch features fully. So I've used the existing role which I have shown. So now let's copy paste the Lambda code which I have already put. So let's do Control C, paste it. We need to make sure, like, put a unique name for this bucket, otherwise we'll be getting one error. So let's quickly go ahead with the deploy. So we are done. Let's create one event. Let's click on test, save it. So we are done. Let's duplicate this tab. We'll be needing two more tabs. One to showcase the S3, that is, it is created automatically. Let me show you that currently there are no buckets created, or no files, or no objects placed in any. So if we click on go back here, see, nothing is there. It's completely empty now. Our Lambda code will also create one bucket and put the CloudWatch logs there. So we'll be basically trailing the logs. So let's do CloudWatch. Let's go to CloudWatch. I'm opening this side by side. So let's click on log groups. Currently we won't be having any kind of log groups because we haven't done anything here. So let's just quickly run this test. It will definitely create one bucket for us, and we can see that the request is successful here. So technically it should create one bucket as well. See, so now if we refresh here, the Lambda, it's appearing now. So if we open this, maybe here if we start tailing, currently it won't show anything because we haven't started, because it starts from this time. Let me change the bucket name and create another bucket. So I'll put one random number here. Now let's deploy. We need to deploy it, right? Otherwise our changes won't be reflected in the final results. So let's now click on test. So whenever just keep on noting, it's blank here. Whatever activity we do related to this Lambda will pop up now. See, everything is popped up. See, our bucket is automatically created. This was the random number we have given. So let's refresh it in the S3 as well. So that's what our purpose was, to create bucket and to tail the activities of the Lambda. I hope you found this tutorial helpful. Alright, let's look at this question. As per the question, it clearly mentioned that the application runs for several hours. Since AWS Lambda cannot run more than 15 minutes, therefore incorrect choice. Let's move to option B. Option B uses Amazon ECS containers. Since the emphasis is on cost, that is, the question is looking for cost effective solution, no operational overhead, using containers can be more cost effective. So we'll park this option aside. Let's move to option C. C uses AWS Elastic Beanstalk. So Elastic Beanstalk will use EC2. If we use a Beanstalk, then each application will get its own EC2 instance, which is more costly than using ECS on EC2, which is option B. Since option B is better than option C, so for now we can reject option C. Let's move to option D. Option D, if we read the main point, it says purchase 3-year reserved instance reservations equal to the group max size parameter of the auto-scaling group. Purchasing reserve instance as per group max size parameter of auto-scaling group is again a costly option. As per the question, we need cost-effective solution. Therefore, incorrect choice, and we'll lock option B as the correct answer. Okay, let's look at this question. It will test your concepts on networking. We'll first look at option A. Option A says set up 3 NAT gateways. Deploying 3 NAT gateways would be more expensive and doesn't provide additional benefits. A single NAT gateway can handle the traffic for all the 3 applications to meet the requirement of the question. Therefore, 3 NAT gateways is not required. We'll reject this. Let's move to option B. B says instead of using the application load balancer, use network load balancer. Replacing application load balancer with a network balancer, load balancer, and assigning the elastic IP address to the network load balancer would not solve the problem of communicating with on-premise system as required by the question. NLBs or network load balancers operate at the transport layer, which is the layer 4, and do not support NAT functionality needed for this scenario. Hence, we'll reject this. Let's move to option C. C says set up 1 NAT gateway in public subnet and give it the elastic IP address. Looks good. Use Amazon CloudWatch to keep an eye on the NAT gateway. If the NAT gateway isn't working properly, use an AWS Lambda function to set up a NAT gateway in different subnet. Give a NAT gateway the same elastic IP address. A single NAT gateway can handle the traffic for all 3 applications. If the NAT gateway becomes unhealthy, a Lambda function can automatically create a new one in different subnet, ensuring high availability. The elastic IP address ensures that the traffic appears to come from the company's IP address range. Since it is also the cost effective as we need, therefore it is the correct answer. We'll log this. Let's bring the heat to the snow. We'll first look at option A. Option A says save the uploaded images in Amazon EFS, and second part says use CloudWatch logs to identify which images need processing. So first of all, Amazon EFS is more expensive than S3, and also EFS is not designed for a web scale application with large number of users. If we look at the question, also second thing, the CloudWatch logs to determine which images need to be processed could be less efficient and more complex than SQSQ. Therefore, incorrect choice. Let's move to option B. Option B says send a message to Amazon SNS. So using SNS for messaging is less suitable use case. SNS is designed for pub-sub messaging and not for passing messages between components in a workflow. And if we read the second part, store them in Amazon EFS, the same reason goes just like option A. Storing the processed images in EFS could be more expensive and less scalable than storing them in S3. Therefore, we'll reject this. We are left out with option C. Option C says save the uploaded images in Amazon S3 bucket. Looks good. Send the messages to the Amazon SQSQ, and the last part says enable Amazon CloudFront and set the origin to the S3 bucket that contains the processed images. So first part, if you look the S3, Amazon S3 is designed for storing and retrieving any amount of data at any time, making it a good fit for storing uploaded images or photos as per the question. Second part, if you look, send a message to the Amazon SQ. So Amazon SQ can handle the messages between S3 bucket and the EC2 instances. And the third part about if you look for the CloudWatch and all, so CloudWatch can monitor the queue depth to scale out EC2 instances as needed. Finally, Amazon CloudFront can deliver and process images quickly to the users worldwide. Therefore, it is the correct answer. We'll first look at option A. Option A says set up an Amazon CloudWatch logs matrix filter to record each successful login as a metric using the username and client name as dimensions for the metric. This needs least changes to the application. As per the question, it's written least modification to the application. So let's park this. We'll move to option B. B says modify the application. Option B, if we read the first three words, it says modify the application, but as per the question, we need to do the least modification to the application. So this is just the opposite of what the requirement of the question is. So on the basis of that, we'll mark this as wrong. Let's move to option C. C says configure the CloudWatch agent to extract successful login matrix from the logs and save the successful login matrix as a custom metric. So CloudWatch agent does not have the capability to extract successful login metrics from the logs and save them as custom metric with dimensions. Therefore, invalid option. Let's look at option D. D says set up an AWS Lambda function, and the second part says increment a custom metric in CloudWatch for each successful login. So option D requires additional Lambda to achieve the goal, which will increase the complexity. Therefore, incorrect choice. We'll lock option A as the correct answer. Alright, let's look at option A. Option A says use AWS Systems Manager Ops Center. So AWS Systems Manager Ops Center is designed for operations management and incident resolution, not for cost optimization. While it can visualize, that is, Ops Center can visualize CloudWatch metrics, it does not provide the automated machine learning based recommendations that Compute Optimizer does. Therefore, we'll reject this for now. Let's move to option B. B says enable CloudWatch detailed monitoring for EC2 instance and their EBS volumes. Create and review a dashboard based on the metrics, identify usage pattern, and adjust the size of the EC2 instances based on the peak metrics. So while CloudWatch provides detailed monitoring, it doesn't offer automatic recommendations for right sizing, which AWS Compute Optimizer does. Identifying usage patterns and right sizing based on peak metrics would require manual effort and may not be accurate. Therefore, incorrect choice. We are left out with option C. Option C is deploy the Amazon CloudWatch agent onto each of the EC2 instance, activate AWS Compute Optimizer and allow it to operate for minimum duration of 12 hours. After this period, examine the suggestions provided by Compute Optimizer and modify the size of the EC2 instances following its guidance. Installing CloudWatch agent on an EC2 on each of the EC2 instances and turning on AWS Cloud Optimizer allows for a detailed analysis of the instance performance and usage patterns. AWS Compute Optimizer uses machine learning to analyze the configuration and utilization matrix of the AWS resources, then recommends optimal configurations. This approach is more automated and precise, and it provides recommendations after running for at least 12 hours. Consequently, this is the correct answer. Let's verify this. In the official documentation. It's mentioned after you opt in to Compute Optimizer, you can view the findings and recommendations that is it generates for your auto scaling groups. If you recently opt in, recommendation might not be available up to 12 hours. So we'll log this as the correct answer. So please don't go away. Gold membership or above is required to unlock member only videos if you want to view. If you additionally want the PDF version of it, including the hands-on files to practice out of your own, and along with the PDF and keyword tricks, then diamond membership or above is recommended.